Hi friends, I'm Daniel. In this video, I'm going to say about models of deadlocks in distributed system. The distributed system allows several kind of resource request and process require a single resource or a combination of resource for its execution. In distributed system, there are many kind of deadlocks. Several kind of resource requests will be sent. Then the resource request may be a single resource or a combination of resource for its execution. And a hierarchy of a request model, or there are four hierarchies. We are going to see about the four hierarchy: the single resource model, AND model, OR model, and OR model. In single resource model, a single process send a request to a single resource. That is a single resource model. If the resource is free, the process will use use the resource. In a single request model, a process have at most one outstanding request for one unit of a resource. In a single resource model, it should have at most one outstanding request for at most one outstanding resource must be there in single resource model. The maximum out degree of the WFG means wait for graph in single resource model is 1, because the resource is 1. In single resource model, the resource is 1, so the out degree of wait for graph is 1. In this cycle, it indicate the deadlock. Then second thing is an AND model. In AND model, in digital we can use an AND gate. For that we have we have to use a two inputs, then only we can get a output. In AND model, a process can request for more than one resource. In this model, a single process send a request to more than one resource. That may be 2, 3 or many. It send a request to one or more than one resource simultaneously. If the request is satisfied, it send the request to two resources. If the two resources are become will ideal, if it is ideal, then it can use the two resources simultaneously, else it will not use. In AND model, the process can request more than one resource simultaneously, and the request satisfied only after all the requested resources are granted to the process. If the two if a process requesting a two resources, if the two resources are become ideal, become free, then only the process will use the resource. The out degree of the graph is more than one, because it should have more than one resources it should have. So the out degree is 1. The presence of life cycle in AND model is indicates deadlock, because if any one of the resource is ideal and one resource is active, the process does not use the one. You can see the diagram. The process P11 is a process, and P21 and P32 are the resources. First, it sent the request to P21 and P32. P32 is used by process P33. P21 is used by process P24. Then P33 releases a P32. Then P32 become free ideal. P11 does not use a P12 and this AND model, because in AND model a process uses a two resources, more than one resources simultaneously. It is an AND model. Then OR model is like an AND model. It also must have a more than one resources. In OR model, the process request numerous resources. A single process request more than one resources. If any one of the resource is ideal, it will use. In AND model, if the two resources is become till ideal, then only it will use. But in OR model, If any one of the requested resources is ideal, it will use that resource. In our model, the process can make a request for numerous resources simultaneously. Simultaneously, it will request for the numerous resources, and the request is satisfied if any one of the requested resources granted. If any one of the resources is granted, then it will use that resource. The presence of life cycle is not imply the deadlock, because it will not make a deadlock, because in our model it will use which resource is ideal, it will use at that time. Then it goes to next example. You can see that P11 and P11 is a process, P21 and P32 are the resources. Process P11 requests P21 and P32. P32 is used by P33, P21 is used by P24. Now P33 releases P32, then P32 become ideal. Now the process P11 in our model, the process P11 uses a P32 and until it gets information. After completing P32, if the P21 is released by P24, then it use. But in AND model, if the two resources become ideal, then only the process uh, can able to access the resources. Next, OR model, and OR model is a combination of AND model and OR model. The generalization of previous two models, AND model and OR model, is an AND OR model. In AND OR model, the request may be specific combination of AND OR. In the AND OR model, the request may be in the combination of AND model and OR model, so it is called as an AND OR model. For example, AND OR model, a request say multiple resource can be the form of X and Y or Z. The request may be in this form, like X and Y or Z is in the form. To detect the presence of deadlock in this model is not familiar to construct a graph theory using a wait for graph. It is not easier to detect a deadlock. If you want to detect the deadlock in this model, we have to do the application repeatedly, then only we can able to detect the deadlocks. That's all, friends. Thank you. We will meet in a next video. Thank you.